Flying at 3 times the speed of sound, the MiG-25 Foxbat is a surprise to American intelligence. The US counters with the F-15 Eagle, America's super fighter. But when a Soviet pilot defects, the Foxbat's true nature is revealed. In autumn 1971, 4 MiG-25Rs like this one were unloaded at Cairo Airport in Egypt. They were referred to as the X-500. Egyptian personnel were kept at a distance. The aircraft were highly secret. From October 1971 through March 1972, they flew reconnaissance missions over the Sinai Peninsula and the Mediterranean. The aircraft had Egyptian markings, but they belonged to the Soviet Union and had Soviet pilots. Reconnaissance flights over Israeli airspace were carried out at speeds of about 2.5 times the speed of sound. An Israeli F-4 Phantom attempted to intercept one of the MiG-25s. It simply accelerated to Mach 3.2 and disappeared. The engines that made the MiG-25's extraordinary performance possible were developed by the Tumansky Group from a design originally intended for a high-speed, remotely piloted drone. Each engine provided vast thrust of almost 25,000 pounds using full afterburner. At the time it was introduced, the afterburner unit was one of the largest ever built. The huge twin vertical fins were designed to provide stability at extreme speeds and altitudes. High-speed roll was controlled not by ailerons, but by all-moving tail surfaces, called slab stabilators. The design of the MiG-25 was directed entirely towards achieving high speed and high altitude. It was not meant to be maneuverable. It was not meant to have good low-speed performance. It was simply meant to travel through the air as fast as Soviet ingenuity could make it go. In the years after World War II, America's capacity to deliver an intercontinental bomb strike developed rapidly. The Boeing B-47 medium bomber was followed into service by the massive B-52 Stratofortress. The B-52 could fly at 650 miles an hour. Its range of 12,500 miles, supplemented by aerial refueling, meant that it could reach any target in the world. The B-52 was developed during the years of the Cold War, and in the Soviet Union was seen as a great threat, with its ability to launch a strike into Soviet territory flying over the North Pole. It inspired a search for higher and higher speeds for Soviet fighter interceptor aircraft. Soviet airspace was immense, and an incoming threat could be located far away from any fighter interceptor station. While the B-52 was still in development, the next stage of American bomber evolution was underway. It was an obvious step. The B-52 could fly at high subsonic speeds. A supersonic bomber would be even more of a threat. The B-58 Hustler was not only supersonic, it could fly at twice the speed of sound. When it entered service in 1960, this powerful and sophisticated aircraft was as fast as any fighter in the world. The MiG-21 had been designed to fly at twice the speed of sound and reach an altitude of more than 60,000 feet. This level of performance was needed so it could intercept a subsonic B-52. But a bomber that could fly just as fast as any MiG-21 demanded new countermeasures. The B-58 was designed to a minimum size concept. The idea was that to keep size down, a disposable armament and fuel pod was carried under the fuselage. It was built in two parts. The lower part that carried only fuel could be dropped off as soon as the fuel was used. The upper part carried more fuel and one bomb, which could be nuclear or conventional. When the bomb was dropped and the fuel used up, the rest of the pod could be discarded, and the B-58, with a completely clean silhouette, could run for home. Aircraft evolution in the years of the Cold War was rapid. While the B-58 was still in development, a project to build a large bomber capable of flying half as fast again was gathering its own momentum. The key to such high speeds for large aircraft was the compression lift theory. The idea was that an aircraft could be designed to trap its own shock wave under its wings and convert otherwise wasted energy into useful lift. The North American Aircraft Company said that using this theory, they could build a large bomber capable of flying 3 times the speed of sound throughout its mission. At the time, the Strategic Air Command had commissioned development work on a nuclear-powered bomber. When North American announced the possibility of the Mach 3 bomber, the Strategic Air Command dropped the nuclear experiments and concentrated on the Mach 3 bomber project, called the B-70. They planned that the first operational aircraft would come into service in 1964. In Moscow, intelligence reports on the B-70 project caused alarm. The problems of intercepting such an aircraft, let alone destroying it, were very great. Surface-to-air missiles were rejected. Instead, a single-seat fighter with extremely high performance, controlled by radar links with a ground station, was seen to be the answer. MiG and Sukhoi were commissioned to develop their own versions of such a machine. A second part of the requirement was that the aircraft be capable of high-speed reconnaissance. It was a major challenge to the design bureaus and to Soviet technology. Test facilities had to be created or expanded. The problems of thermodynamic heating had to be confronted. Metallurgy and electronics far beyond the Soviet state-of-the-art in the late 1950s were called for. New engines had to be developed. Even the facilities of major research institutes like Tsagi were extended by the scope of the project. By the end of the 50s, a great deal of development work had been done, but in 1960, an American U-2 spy plane took off from Pakistan on a high-altitude reconnaissance mission that would dramatically change the defense relationship between the United States and the Soviet Union. Development of the U-2 began in 1954. The prototype flew in the summer of 1955. At the time, American President Eisenhower was proposing his open skies policy. The Soviet Union rejected the proposal, and the U-2 went into service as a spy plane, able to fly above Soviet territory at altitudes beyond the range of any interceptor or missile. In June 1956, operational U-2s were stationed in West Germany and began making flights over Moscow and Leningrad. Francis Gary Powers' flight on May 1st, 1960, was intended to take him from Pakistan across the Soviet Union to Norway. On May 5th, 1960, at the Soviet Presidium, Nikita Khrushchev announced that Powers' U-2 had been brought down 1,400 miles inside Soviet territory. At the time, a major Big Four summit conference was about to be held. At first, US authorities denied that the U-2's mission was espionage, but eventually they conceded that it was, and that such flights by unarmed aircraft had been going on for a number of years. A State Department spokesman, Lincoln White, was given the job of announcing that spy flights were justified.
Intelligence collection activities are practiced by all countries, and post-war history certainly reveals that the Soviet Union has not been lagging behind in this field.
When the remains of the U-2 were put on display in Moscow, Lockheed authorities were able to deduce that a Soviet SA-2 surface-to-air missile had knocked off the right-hand stabilizer. The aircraft had inverted at high speed and the wings broke off. Because of high G-forces, Powers was unable to reach the destruct button to destroy the airplane, and he had to eject. Nikita Khrushchev charged America with deliberate aggression and said that the world could be pushed to the brink of war. It was a diplomatic disaster for the US, but just as disastrous for Air Force strategies was the knowledge that Russian missiles were good enough to reach and disable an aircraft flying at extreme altitude. When Khrushchev arrived in Paris for the summit conference, the Allies were scrambling to try and find a way out of an embarrassing mess. US President Eisenhower agreed to cancel the U-2 flights, but refused to apologize to Khrushchev for the Powers mission. The summit meeting collapsed on its second day.
The hopes of humanity call on the four of us to purge our minds of prejudice and our hearts of rancor. Far too much is at stake to indulge in profitless bickering.
In Moscow, at the MiG factory, Mikhail Gurevich headed the team responsible for the design and construction of the Soviet high-speed interceptor project. At the same time, in America, the North American company was testing its new carrier-based attack aircraft, the A-5 Vigilante. The Vigilante could fly at more than twice the speed of sound. It could also act as a bomber carrying nuclear or conventional weapons. The prototype Vigilante had flown in 1958, about the time the Russian Air Force funded the development of the Soviet Mach 3 interceptor. There is still argument between American and Russian authorities about the extent to which MiG used the Vigilante as a starting point for their design. MiG's prototype was called the E-155. The basic design was created by Artyom Mikoyan. For a single-seater, it was a very large aircraft. It had to be, to carry the huge Tumansky afterburner turbojets being developed to power it. Design work continued through 1961, and by the middle of 1962, construction of the prototype began. Conventional aluminium alloys were not suitable for an aircraft that was to fly as fast as this. MiG chose to work in a material largely ignored by Western aircraft manufacturers, steel. Most of the E-155 was built of nickel-steel alloys. Titanium, extremely expensive and difficult to work, was only used in places where the heat loads were expected to be highest. The structure was arc welded, rather than using the traditional Soviet method of riveting. In fact, the welding process was less labor-intensive than riveting, and since the aircraft would be much bigger than its predecessors, it was important to keep production costs down. Weight had to be kept to a minimum. To some extent, weight was traded for strength. The E-155 was designed to withstand a maximum load of only 5 Gs. Most fighters are twice as strong. But the interceptor's mission was to fly fast, and there was a price to pay to achieve extreme speed. The project's chief designer was Nikolai Matyuk. Lev Shengelaya was his assistant. Matyuk had been at the MiG Bureau since its very first day of existence, December the 8th, 1939. Forged steel was used for the main structural members of the prototype. Titanium was used for the leading edges and around the tailpipes, but aluminium was used for some of the parts less exposed to the effects of heating at high speeds. Welding was used extensively. It was used to build up some complex structural components that would have been forged in the West. In the United States, at the same time the MiG-E-133 was being built, work was advancing on an American interceptor designed to fly at speeds above Mach 3. It was the Lockheed YF-12, a high-speed, high-altitude aircraft, fast enough and maneuverable enough to avoid any Soviet surface-to-air missile. Lockheed's designers, like those at MiG, had faced the problems of extreme temperatures generated at high speeds. Like the Russians, they had rejected aluminium because it wouldn't withstand temperatures over 800 degrees Fahrenheit. They considered stainless steel and titanium, but Lockheed designer Kelly Johnson decided that titanium would be simpler to work with. The YF-12 had a large fuselage which could easily carry 3 Hughes GAR-9 missiles. Launching them was a different matter. No one had ever launched a missile at the speeds and altitudes the YF-12 could attain. The main problem was to eject the missile and ignite it so it wouldn't come up and hit the aircraft. The answer was not to ignite it until it had dropped 40 feet below the fuselage. It was a time of shrinking defense budgets. Secretary of Defense Robert McNamara decided that America's potential enemies had nothing comparable, and there was no need for such a high-performance interceptor. This is film taken in the Soviet Union on March the 10th, 1964. It is the first flight of the E-155, the prototype of what was to become the MiG-25. In the air, the similarity in layout to North American Vigilante is obvious. The main difference is the large twin vertical fins. MiG designers were concerned about the directional stability of the aircraft at extreme speeds, and there was a degree of overkill in the prototype. There were extra vertical surfaces on the wingtips and fairings which were meant to prevent wing flutter. Eventually, they were discarded. But the E-155 continued to suffer from control and stability problems that took a long time to overcome. The test pilot for the first flight was the great Alexander Fedotov. As he gets out of the cockpit, he gives some idea of the size of this new Soviet interceptor. This is the test rig used to develop the radar and the weapons control system of the MiG-25. It was entirely new. No existing Soviet radar was powerful enough to meet the Air Force's search and track requirements for the high-speed interceptor. The new radar was called the RP-25 Smerch, which means whirlwind. In the West, it became known as the Foxfire. It was designed to burn through any known jamming system at a range of up to 50 miles. It weighed 1,100 pounds, the largest and heaviest of its kind in the world. The purpose of the Smerch radar was not to detect or track a target. It was designed to provide a final, accurate target fix that could not be jammed, so the pilot and ground controller could position the aircraft for missile launch. In May 1964, just after the first flight of the Soviet E-155 interceptor, the long-awaited XB-70 Valkyrie rolled out of its hangar in Palmdale, California. By now, it was no longer a threat to the Soviets. It had been cancelled by the Kennedy administration. The threat of cancellation had hung around the Valkyrie project for some time. It was cancelled for the first time in 1959 and then reinstated in 1960. The final cancellation took place in early 1961, and the XB-70 prototypes were downgraded to research status. One of the reasons for the cancellation was that the U-2 incident in 1960 had demonstrated that Soviet surface-to-air missiles were more advanced than the West had suspected. Another was that the growth of ballistic missile technology was forcing a reassessment of long-range strategic bombing. And a third was that the Valkyrie project was extremely expensive. On the face of it, the cancellation of the XB-70 project might well have killed the MiG Mach-3 interceptor, but it didn't. Work proceeded for several reasons. One was that the XB-70 research program was continuing, and there was a possibility the cancellation could be reversed again. Another was that the new Soviet fighter could be used against the existing supersonic bomber, the B-58 Hustler. As the test program of the MiG-25 prototype continued, Artyom Mikoyan, the general designer of the MiG Bureau, was concentrating on the development of the MiG-23, the new Mach-2 swing-wing fighter. Mikoyan had designed the basic layout of the MiG-25 prototype, but had been advised to avoid full commitment to such a demanding program because of risks to his health. In March 1965, his bureau made the first public announcement of performance figures achieved by the MiG-25 prototype. It had flown around a closed 1,000-kilometer course at an average speed of more than 1,400 miles an hour. Western defense analysts assumed that the aircraft was a development of the MiG-21, but they had a surprise coming. In 1967, the 50th anniversary of the October Revolution was celebrated by an air show at Domodedovo Airport outside Moscow. Late in the show, there was a pass by a group of aircraft that the show announcer referred to as interceptors capable of Mach 3. Western defense analysts were puzzled by this announcement. No one believed the announcer's claims of performance. For a time, there was a misconception among some experts that the aircraft that flew by at Domodedovo were MiG-23s, the new MiG variable geometry fighter. Ironically, Russian enthusiasts who read the Western aviation press believed the same thing. They had nothing else to go on. There was very little public information about the MiG-25 anywhere, even in the Soviet Union. This confusion persisted till 1972, and the Soviets did nothing to clarify it. With the cancellation of the XB-70 Valkyrie and the YF-12 Interceptor, the MiG-25's secondary function, high-altitude reconnaissance, assumed greater relative importance. The cameras fitted to the MiG-25R were capable of taking detailed pictures of the whole of the United Kingdom in the course of one flight. Reconnaissance MiG-25s could communicate directly with ground stations through a data link system. The MiG-25R, the first-generation reconnaissance variant, had 5 cameras in its large nose compartment and a limited capability side-looking radar. The later electronic intelligence version had no cameras. It relied on a large number of electronic sensors and a more powerful radar. The reconnaissance version gave the West its first close-up glimpse of a MiG-25 in service conditions. In the late 1960s, the United States Air Force was writing requirements for a new tactical fighter. The aircraft that resulted was the McDonnell Douglas F-15. the complexity and sophistication of its design and construction was strongly influenced by the West's vague understanding of the nature of the new MiG-25. In October and November 1967, MiG-25s set a number of speed and altitude records. They carried loads of 2 tons to altitudes of almost 100,000 feet. They flew 1,000-kilometer closed courses at speeds of more than 1,800 miles an hour. From these figures and other intelligence information, Western analysts made several false assumptions, all of which affected the design and construction of the F-15. One was that the MiG-25 was faster in a straight line than was really the case. The second was that it must be built from highly sophisticated lightweight materials. The third was that it was powered by a sophisticated turbofan jet engine. They also deduced that it had long range and good close-in combat performance. When the F-15 emerged, it was an extraordinary machine, a genuine air superiority fighter, also capable of ground attack, with long range and very effective radar. It was extremely complex and extremely expensive. And the Soviet adversary that had so strongly influenced its design did not really exist. The F-15A was ready for its first flight in July 1972. At the same time, the Foxbat was flying its reconnaissance missions over Israel in Egyptian colors. In Russia, the first service models were being introduced into Soviet Air Force squadrons. The American military still did not understand the true nature of the Foxbat, but they did have extremely high expectations of their own new superfighter. The F-15's performance through the test program was excellent. It verified that the enormous amounts of money poured into the F-15's development had bought what the military had paid for, a genuine superfighter. Very early in its career, the F-15 set out to defeat the Foxbat. Not in combat, but in the field of time to climb records, where an aircraft tries to reach a given altitude in the shortest possible time. By the mid-70s, time to climb records established by the Foxbat had been broken by the F-15 Eagle. The MiG-25 began to enter service in the Soviet Union in late 1971 and early 1972. For Soviet Air Force pilots, it opened up entirely new dimensions of performance, and a dedicated trainer version was essential. It was called the MiG-25U and had a completely redesigned nose with 2 separate cockpits. The pilot sat in the high cockpit at the back and the student in front. The trainer's performance was just as good as the single-seater, and a second armed version was developed, able to carry air-to-air missiles. By 1976, MiG-25s had been in service for almost 4 years, but still no one in the West had seen one up close, and the mysteries of the Foxbat's real nature still existed. Then, on September the 6th, a MiG-25 took off from the Sakharovka Air Base at Vladivostok and landed, quite unexpectedly, at a Japanese airport. Its pilot, Viktor Belyenko, had defected. Western authorities examined it minutely. Some of the myths were at last dispelled. It was heavier and simpler in construction than had been supposed. Its range was shorter. It was not a close combat fighter. Its brutally powerful jet engine had poor low-speed performance. The truth was out. The MiG-25 was indeed an extraordinary aircraft, but it was not the one the West had imagined. It continued to set world records throughout the 70s. 16 of them were established by Mikoyan chief test pilot Alexander Fedotov, including a world absolute altitude record of almost 121,000 feet, which still stands. The MiG-25's enormous thrust-to-weight ratio made it perfect for climbing almost straight up. Boris Orlov reached 64,000 feet in 2 minutes and 50 seconds. Pyotr Ostenko reached 96,000 feet in 3 minutes and 10 seconds. The Foxbat was also fast, flying straight and level and around a circuit. Mikhail Komarov completed a closed 500-kilometer course at an average speed of 1,850 miles an hour. Svetlana Savitskaya set 4 world speed and altitude records. Later, she became the second female Soviet cosmonaut. Throughout the 1970s, upgraded and improved versions of the MiG-25 were introduced into service. They were also supplied to a number of foreign countries: Algeria, Egypt, Libya, Syria, Iraq, and India all bought MiG-25s from the Soviet Union. The MiG-25 is a deadly weapon, but it is loved in the Soviet Air Force for a reason nothing to do with its capability as an interceptor or reconnaissance aircraft. Its Russian nickname is Spyotovoz, the alcohol carrier, because it carries 300 liters of pure alcohol for the cooling system. At outlying Air Force bases all over Russia, visiting MiG-25s are greeted enthusiastically with a variety of potential alcohol containers. When Rostislav Belyakov took over the MiG Design Bureau from Artyom Mikoyan, he faced a new problem. The MiG-25 had been designed to counter the high-altitude Mach 3 B-70 Valkyrie. The Valkyrie had never gone into service, but Soviet fighters, missiles, and radar systems were generally biased to detect and intercept high-altitude intruders. Now a new threat loomed. America was developing a bomber which could penetrate Soviet airspace at low altitude. The Rockwell B-1 never went into service. Its development was cancelled in 1977 by President Carter. But eventually the B-1B, a subsonic derivative, was developed. Low-flying bombers like the B-1 and the B-1B need to be detected by look-down radar that can see a target against the ground. In the late 70s, Soviet authorities were concerned about B-1Bs coming in over the North Pole carrying cruise missiles. An interceptor to counter such a threat needed to have an extended range, be able to operate autonomously, and have a new radar system. In the late 70s, 2 new fighters, the MiG-29 and the MiG-31, were being developed by Mikoyan. The MiG-31 developed directly from the MiG-25, but even though they look similar, they are very different. The MiG-25 is a single-seater. The MiG-31 has a crew of 2 and a completely redesigned front end. Under the skin, it is virtually a new aircraft. The second crew member in the MiG-31 is a weapons system officer who interprets radar information and takes control of the weapons out of the hands of the pilot. Development of the MiG-31 began in the early 1970s. The MiG-25 design was a good starting point because the new aircraft needed to carry a heavy weapons load and enough fuel to allow for extended periods of loiter time in the air. It also needed to be large enough to carry a powerful new radar system. It would need to be fast, reasonably maneuverable, and strong. The MiG-25's enormous Tumansky jet engines were not suitable for the new task. They were designed only for high-speed performance. They were too inefficient and used too much fuel. New, lighter Solovyov turbofan engines were available, but the fuselage had to be stretched to fit them, and the intakes had to be redesigned and enlarged. The fuselage had to be strengthened. The MiG-31 needed to operate freely at low altitude, where the dense atmosphere places great stress on aircraft flying at high speeds. By the time development work on the MiG-31 finished in the early 80s, it had evolved into a new aircraft. It was structurally different and powered and armed differently from the MiG-25. And its mission was almost the opposite of the requirements that had brought the MiG-25 into existence. The radar, a powerful phased array system, was new to the Soviet Air Force. It could distinguish targets from above, hence the title, Look Down, Shoot Down. In ordinary radar systems, the radar dish itself moves. The scan time is controlled by the speed at which the system can physically swing back and forth. It was a challenge to Soviet technology to develop a system that could break free from this physical limitation. In the phased array system, the radar dish stays still and the beam itself is moved. It can be thrown from the extreme right to the extreme left in milliseconds. This allows the weapon system to fire at several targets, guiding 4 missiles in different directions at the same time. The US Navy F-14 Tomcat has a similar radar system, but it can only fire at targets remaining in one plane, and it has less search and track range than the MiG-31. The MiG-31 was the first fighter to have a phased array antenna of this type. The MiG-31 has special equipment to share information with other aircraft in the group. This allows coordinated attack on incoming targets. The heads-up screen in the cockpit can display radar information, a moving map, and the weapons control panel. Special equipment continually measures the coordinates of other MiG-31s in the group, so each one always knows exactly where the others are. At a range of 150 kilometers, the radar can track up to 10 targets at the same time and automatically identify whether they are friends or foes. The 4 targets the system considers to be the most dangerous are automatically selected by the computer and assigned for simultaneous firing. When several MiG-31s are flying together as a group and they encounter large numbers of targets, it's important to decide which plane picks up which target. The weapon system of the MiG-31s allows this to happen in a coordinated manner and even builds in the possibility of some deceptive maneuvering. None of the MiG-31's rival fighters, the F-14, the F-15, or the Tornado, can talk to their group members through digital links and coordinate a team effort. The MiG-31 has high supersonic cruise capability. It can also fly at higher altitudes than incoming escort fighters. With this performance and its look-down, shoot-down weapons system, it has the advantage of firing from above its opponents while moving at higher speeds than they are. The MiG-31's missiles are not carried on hard points under the wing. They are launched from semi-recessed storage positions under the fuselage. The development of the MiG-31 was time-consuming and difficult. There were major systems development problems, and it took several years before the aircraft was cleared for service. Delivery to operational units began in 1983. Priority was given to sending the aircraft to areas considered by the Soviet Air Force to be underprotected. Through the 80s, it was distributed widely across the Soviet Union, from Arkhangelsk in the west to Sakhalin Island, north of Japan. Russian sources say that in the mid-80s, Soviet bases on the Kamchatka Peninsula were feeling pressure from Japanese and American flights close to Soviet airspace. A unit of MiG-31s was sent there, and after they'd been in service for a short time, the number of flights close to the border decreased dramatically. The MiG-25 was not a dogfighter. Neither is its descendant, the MiG-31. Its power comes from high speed, high altitude performance, and the ability to engage an enemy beyond visual range, an enemy the pilot will never set eyes on.